Hello everyone, this is Nidhi Kumari with student ID 105-03164. This is my student project and I am going to demonstrate to you about IP and NAT in this video. I will give you the basic understanding along with the tool used for packet capturing for live demonstration of these protocols. For this, we will be using real-time packet capturing tool Wireshark. So now what we'll do is we'll open Notepad and I'll brief you briefly what IP is. Okay, so now IP. IP stands for Internet Protocol and is used to establish and make a communication with outside world with an identity. It is the method or protocol by which data is sent from one computer to another on the internet. Okay. So it can happen across a single network or a series of interconnected networks. It is of two types, IPv4 and IPv6. IPv4 has a 32-bit address length, whereas IPv6 has 128-bit address length. When IPv4 address representation is in decimal, whereas address representation of IPv6 is in hexadecimal. Most frequently protocol used now is IPv4 and IPv6 is still developing. Now NAT. NAT is the short form for network address translation and is used to make communication with outside world devices from outside our company's internal network. NAT uses one set of IP addresses for internal traffic and a second set of addresses for external traffic. A NAT box located where the LAN meets the internet makes all necessary IP address translations. NAT enables a company to use more internal IP addresses. Since they are used internally only, there is no possibility of conflict with IP addresses used by other companies and organizations. It also translates the IP addresses of the computers in the local network to a single IP address. This address is often used by the router that connects the computers to the internet. Also, we will discuss here about encapsulation. So what encapsulation is? NAT allows encapsulation. What it is that it provides a type of firewall by hiding the internal IP addresses. So here we have discussed about what IP and what NAT is. So we will move on to perform the practical of capturing the packets. Okay, for this we are going to run Wireshark on our Wi-Fi adapter. Okay, so here we are connected to the Wireshark and you can see that here all the connections are there. Okay, so now as you can see we have local area connection, Wi-Fi, local area connection again, and adapter for loopback. So here as you can see that we are connected to internet via Wi-Fi. Okay, so these all are menu options of the Wireshark network adapter like file, capture, analyze, statistics, telephony, etc. Now we have what we have opened, we have started capturing the packets. Now we will now open a website google.com. okay, so that we can capture the packets. So now we can minimize the browser and see all these packets are displayed or are captured. You can see a lot of protocols over here. You can see MDNS and you can see TCP. Okay, so now what you can do is you can stop the packet capturing with this red button on the menu bar. Okay, so you can see all these packets have been captured. Okay, you can see all these packets that have been captured. Okay, so now we have to apply filter to only look for IP packets. and can search only IP packets and can see. So now for applying filter, what do you have to do is, okay, you have to go for to filter, apply a display filter. Okay, yeah, you will write you will write what, IP. Okay, now when you write IP over here, see, all it displays is the IP packets. Okay, see, we can see internet protocol, it's version 4. We can see the source and the destination IP address. The source is 192.168.1.6 and the destination is 224.0.252. What the version here, we can see clearly the version is 4. Okay, yes. So now you can see the other things also, including source and destination, what we have just saw. Okay, now we can also see what our internet configurations are. See, we have used this IP config command on our command shell. Yeah, so we can see all the IP addresses, IP configurations for our different adapters. See, we can see for wireless LAN adapter. Okay, we can see for Ethernet adapter. We can see IPv4 addresses of all the adapters present on our device. So see, this is wireless LAN adapter Wi-Fi. The IPv4 address is 192.168.1.6. So this is our IP address, and this is also displayed as our source IP address. Okay, and this destination is the packet to this is the IP address to which our packets are being transferred. Okay, so this is our destination IP address. You can also see the other things such as header length, which is 20 bytes, the total length of the packet, which is 50, flags, time to live, and the other things. Now we can see this is a protocol UDP, user datagram protocol. Okay, see this 17, what you see is the port number. Okay, so this UDP is it is essential, and we can see the port number is 17. Now what types of protocol are there? Like there are two types of protocol basically. One is TCP and one is UDP. So the TCP protocol stands for Transmission Control Protocol. Let me write it. Yeah, it stands for Transmission Control Protocol. Yeah, and the UDP, it stands for User Datagram Protocol. So these two are the main protocols, and all the other protocols are just divided according to these two protocols. Okay, so the port number is for UDP is 17, as we all know. Okay, we saw just now. We can see the header checksum, and whose validation is disabled for security purposes. Header checksum status is unverified, obviously, because it is disabled. We can see the source and destination, and we can see the port number, source port number, and the destination port number. Source port number is 57578 and this destination port is 5355. We can see checksum status and timestamps. Timestamps are very necessary for just verifying that how much time frame, what is the time of the time frame it took for packet capture or transfer. So time since first frame is obviously 0.0 seconds. Okay, and time since previous frame, like when we started capturing, is 0.0 second. So we have other things such as linked local multicast name resolution, where we have authority, additional, and now also we can see queries. So type A, what does type A stands for? We've used google.com, so it is type A. So again we started. So what now? Protocol. So you do not see protocol just like that NAT. You have to write DNS and filter, and then you can see all these packets of NATs here. So all these, so we have just stopped capturing, and all you can see is the packets captured with DNS protocols. These all are captured NAT. We can see this protocol in NAT DNS packets with its queries and flag and transmission with other details too. See, the source is Huawei. This is 74:5A:AA:75:D9:EC, and the destination is 5E:70:2C. So this what the source is. Source is the MAC address of the device, and the destination is like, destination is what? Destination is the map, is the address of the the transferred packet address, the transferred device address. We can also see other things such as internet protocol version, and obviously the source and the destination IP addresses. And the total length, that is 290, and the other is differentiated services field. So whatever is there, you can see flags is 0 into 4000. We have not fragmented it yet. Okay, again you can see the user datagram protocol, and the port number is 17, and you can see the source and destination, everything over here, all the essential details. Okay, also you can see the source port number. And now we come to DNS, domain name system. You can see transaction ID, the flags, the questions and the answers, and the queries. We have used obviously www.google.com, so we have used this main address, google.com website, and which is of type A. Obviously it is a standard website, and this is the class of the